In order to properly protect migratory birds, we need to know where they breed, where they spend the non-breeding season, and how they travel between the two locations. We are still learning about the paths that migratory birds take, the stops that they make along the way, and where specific populations spend their non-breeding season. Migratory connectivity is the geographic linking of individuals or populations between different annual life cycle stages. Knowledge of a species' migratory connectivity is essential for effective conservation, so that the threats that populations experience throughout the annual cycle can then be better assessed and managed. However, we have not established these linkages for most species and have only monitored many populations at one end of migration or the other. One such species is the willet. The world's willet population is composed of two distinct subspecies that are separated by breeding habitat in North America, with eastern willets breeding in the marshes along the Atlantic and Gulf coasts, and western willets breeding in wet grasslands and prairies in the interior west of North America. On the Atlantic and Gulf coasts of North America, western willets replace eastern willets during the non-breeding season. Because western willets are present in North America during both the breeding and non-breeding seasons, their presence is well documented there. However, where eastern willets spend the non-breeding season has not been fully investigated. Connectivity for breeding eastern willets is important because factors influencing conservation strategies may differ by nesting location, overwintering range, or migratory route. The conservation status of the willet is a concern for several reasons. First, the future of willet breeding habitat is uncertain. Coastal wetlands, by their nature, are limited in extent, and although many salt marshes in the eastern U.S. have protected status, their future may be in jeopardy as the effects of sea level rise due to climate change become increasingly apparent. Eastern willet nests are susceptible to tidal flooding events, and sea level rise will only exacerbate the problem. Additionally, salt marsh breeding birds are subject to several human-caused disturbances, including habitat loss through development, oil spills, and recreational disturbance that result in nest failure. For these reasons, the willet is considered a species at risk of extinction unless its decline is reversed and the threats are lessened. In summary, breeding eastern willets are susceptible to a host of threats that do not impact breeding western willets. The study of migratory connectivity has been advanced by new tracking technologies, including the advent of lightweight, inexpensive archival light-level geolocators. Light-level geolocators are tracking devices that use daylight to estimate the location of a bird. A light-level geolocator has a light sensor, an internal clock, a battery, and a computer that stores a measurement of the amount of light that the sensor is exposed to. The sun rises and sets at different times depending on where you are in the world. So by tracking the timing and amount of light that these sensors are exposed to, we can determine approximately where the birds are. These devices can be carried by birds to record their location as they travel between breeding and wintering areas and have been successfully used on many shorebirds. Migratory connectivity studies of Atlantic coast breeding eastern willets, which we will hereafter refer to as Atlantic coast willets, using these geolocators, indicate that those birds spend the non-breeding season along the Atlantic coasts of northern South America, primarily in northern Brazil. However, to date, no one has investigated where the Gulf breeding eastern willets, which we will hereafter refer to as Gulf Coast willets, spend the non-breeding season. With this in mind, Gulf Coast Bird Observatory and the Texas Mid-Coast National Wildlife Refuge Complex studied the migration of breeding eastern willets on the Texas coast from 2015 to 2019. The objectives of this study were to determine the timing, routes, non-breeding locations, and migratory connectivity of these birds. Our study site was at San Bernard National Wildlife Refuge in Texas, where we located willet nests. For every nest, we noted the number of eggs and marked the area with dowel rods. For nests containing 3 to 4 eggs, we returned a minimum of 1 hour later and lowered a mesh mist net suspended between 2 poles over the nest. We then approached the nest to flush the incubating bird into the net. Once captured, we applied an aluminum band, 2 color bands or a leg flag, and a leg-mounted geolocator. Relative to our individual bird weights, these markers comprise no greater than 1.86% of the body mass. We also measured wing chord, culmen, and weight. We returned at a different time of day to trap the uncaptured pair member, as there is evidence that incubation is temporally spaced in willets. We always attempted to capture both of the pair members each year, but sometimes failed due to nest completion, nest termination, or bird wariness. In subsequent years, we retrieved geolocators by recapturing the tagged birds. In total, we located 40 nests from which we banded 30 birds and deployed 24 geolocators. From 2016 to 2019, we retrieved 9 geolocators with data. This is what we gathered from that data. Our willets departed the Texas coast breeding site from July 5th through the 26th. 8 of the 9 individuals made a direct flight from the breeding grounds to the wintering grounds, while 1 individual appeared to make a 1-day stopover somewhere on the Atlantic coast of Mexico. Southbound migration lasted 2 to 5 days, with the willets arriving at their wintering sites from July 8th through the 30th. 5 individuals wintered on the coast of Ecuador or northern Peru, with 2 individuals wintering on the coast of Nicaragua or Costa Rica, and 2 individuals wintering on the coasts of Panama or northern Colombia. 4 tags stopped collecting light data before the northbound migration. 4 of the remaining 5 individuals departed the wintering grounds from March 9th through the 24th. We could not accurately estimate the paths of their migrations, but they appeared to spend 3 to 4 days migrating back to the breeding grounds, arriving back in Texas from March 13th through the 27th. 1 individual remained on the wintering grounds in Ecuador at least through June 8th of the following breeding season, when its tags stopped collecting light data. This individual returned to the breeding grounds for the 2017 breeding season and all subsequent seasons. Interestingly, one of our mated pairs, M568 and X059, from which we recovered geolocators, did not travel together or overwinter in the same country following their southbound migration. The female, M568, departed on July 11th and arrived in Ecuador or northern Peru on the 15th of July, while the male, X059, departed on July 9th and arrived in Nicaragua or Costa Rica on the 11th of July. But the pair returned to the breeding site and nested together for the following year. It appears that some couples booked separate vacations. This is the only data recovered for simultaneous time periods from both pair members in our study, and we are unable to speculate how commonly this occurs. Our study provides the first evidence that there is likely little range overlap throughout the annual cycle between Atlantic coast willets and western Gulf Coast willets on the wintering grounds or any other phase in the annual cycle. The evidence to date regarding wintering ranges indicates that the Atlantic coast willets winter primarily along the Atlantic coast of northern South America, with small numbers occurring as far south as Argentina. In contrast, western Gulf willets winter on the coasts of Central America and the Pacific coast of northern South America. In both regions, it appears that eastern willets are wintering in mangrove-dominated estuaries, with large tidal ranges that have, in many cases, been previously identified as important sites for shorebirds. Although they occupy similar coastal habitats, willets wintering on the Pacific coasts of Central and South America may face different types and magnitudes of threats than those wintering on the Atlantic coast in the Guianas and Brazil. For example, in Brazil, although wetland conversion to shrimp aquaculture looms as a threat, the core wintering areas remain relatively undeveloped. Conversely, on the Pacific coast, considerable development has already occurred. The coastline of Ecuador, where the majority of willets we tracked wintered, has experienced extensive conversion of coastal habitats into shrimp farm ponds over the last 50 years. Shrimp farms are the dominant land cover in half of Ecuador's major estuaries and occupy more space than mangroves in 3/4 of the estuaries. This level of habitat loss for feeding and roosting may ultimately reduce shorebird populations. Observations over the past 5 years indicate that willets and other shorebirds wintering along the Pacific coast of Central and South America are forced to use dikes next to empty ponds for roosting due to loss of natural habitats from shrimp farming. This is a concern because of the use of exploding gunpowder as a non-lethal control mechanism to scare away shrimp predators such as cormorants and gulls, which also roost on the dikes. Additionally, alterations associated with shrimp aquaculture have undoubtedly changed the estuary hydrology, and the effects of this are unknown. Beyond the threat of shrimp farming, coastal habitats in the neotropics are threatened by commercial, industrial, residential, and agriculture development. Shorebird hunting is also a concern in the Caribbean and northern South America. There are also issues with diffuse pollutants from agriculture, aquaculture, and cities, which contaminate the tidal waters used for foraging by shorebirds. While Atlantic coast willets and Texas Gulf Coast willets do not have overlapping winter ranges, individuals we tracked did overlap with overwintering western willets on the Pacific coast of Central and South America. The presence of eastern willets along the Pacific coasts of Central and South America has not been previously recognized. Current shorebird plans treat all wintering Pacific coast willets as westerns, so an adjustment to shorebird plans is necessary to account for this new information on the distribution of eastern willets. Distribution and population assessment of eastern and western willets continues to be hampered by inconsistent subspecies assignment during shorebird survey efforts on the wintering grounds and stopover sites. The differing winter locations of Texas Gulf Coast versus Atlantic Gulf Coast willets points towards the need for distinguishing between the subspecies and subpopulations when generating population assessments and conservation planning efforts. These results indicate that shorebird plans and survey techniques inclusive of non-breeding willets on the Pacific coasts of Central and South America should be adjusted to consider the possibility of eastern willets in these areas. Thank you for watching this video and learning about our willet research. To learn more about this study and our other conservation work, visit us at www.gcbo.org.